Welcome to Learn with Roblox. Today's topic is going to be special right triangles, so let's get right into it. There are two different special right triangles that I need to be aware of. These are the 30-60-90 triangles and the 45-45-90 triangles. The reason they're called those is that those are the angles in those triangles. So let's talk about what's so special about these triangles. In the 30-60-90 triangle we have over here to the left, it has a special side length ratio. The way this ratio works is that, say that the 30 side, we denote it as x. It's x units long. We know that the 60-degree side is now going to have a side length of x root 3. And the side opposite of 90 is just 2x. And this ratio is just specified by the angles. And we'll get into a few problems dealing with this. But to move on to the 45-45-90 triangle, the ratio that you need to know is each of the sides opposite to the 45-degree angles is x. Or Rx rather. And then the side that's the hypotenuse is just x root 2. Let me rewrite that. So now let's dive into a few practice problems to help us understand these ratios. Here, I've given you a triangle where the side that's opposite to the 30-degree angle is 7, and I want you to find the other two sides. Well, first, we know that the 30-degree side is x in our ratio, so I'm just going to write down that 7 is equal to x. And what do you know about the other two sides? Well, the 60-degree side is just x times square root of 3, and the other side, the hypotenuse, is just 2x. And notice how, since we already solved that 7 is equal to x, we can simply plug in 7 into x root 3 and 2x. So let's do that. If we do that for the 60-degree side, we get 7 square root of 3 as the answer. And you want to put that into a calculator, it's about 12.12. And then for the side that's 2x, well, 2 times 7 is just 14. So now we know the lengths of all the sides. Let me just clean this up. So the hypotenuse is 14 units long, and the side that's opposite of 60 is 7 times square root of 3. Or 12.12 if you prefer. So the next problem I have is a 45-45-90 triangle where the hypotenuse is 6. To solve this problem, I'm going to recall that a 45-45-90 triangle has side lengths that are in the ratio of x, and x times square root of 2. And since we have 6 is equal to x times square root of 2, if we solve for x, we're going to be done. So what I'm going to do is, I'm going to set up this equation just at the top again to give us some more space. And if I solve for x, I'll know what the legs of this triangle are. So first, divide by the square root of 2 on both sides. Those will cancel, and we're just going to be left with 6 divided by square root of 2 is x. But we need to rationalize the denominator because we don't want to have square roots in the denominator of a fraction. So to rationalize, the way you do is you just multiply by the denominator again on the top and the bottom. So I'm going to have 6 divided by square root of 2 times square root of 2 divided by square root of 2. If you do that, you get 6 divided by the square root of 2 divided by 2. Because when you multiply square root of 2 by square root of 2, the square root pops off and you just have 2. And you can further simplify this because 6 divided by 2 is just 3. So you have x is just equal to 3 times the square root of 2. So I'm just going to replace these x's with 3 root 2. And I'm going to rewrite a 6 here for the hypotenuse and just erase all this work to clean it up a bit. So now we've solved this 45-45-90 triangle. The side lengths are 3 root 2, 3 times square root of 2, and 6. And if you want to know what 3 root 2 is as a decimal, you just put it into a calculator. It's about 4.24. Alright, now let's move on to the next problem. Here, I've given you a 30-60-90 triangle where the side opposite of 60 degrees is 5, and I want to find the perimeter. To do that, we need to find the other two sides of this triangle and then sum every side. We know that 5 is equivalent to x root 3 in our ratio, right? Because the side opposite of a 60-degree angle is x root 3 in the ratio in a 30-60-90 triangle. So all we need to do is solve for x, and it'll help us find the other two sides. So let's solve for x. Once again, divide by square root of 3 on both sides. And just like that, the square root of 3's will cancel on this side. And you're left with x is just equal to 5 divided by square root of 3. But once again, we don't want to have a square root in the denominator. So let's rationalize this. The way to do that is multiply by square root of 3 for the numerator and the denominator. And if you do that, you're going to get 5 divided by the square root of 3, or 5 times the square root of 3 rather, divided by 3. And this is just x. And now this will help us find the other two sides. So now we know that the side that's opposite of 30 degrees is just x. So this side is simply 5/3 times square root of 3. That's just another way of writing it. And then the hypotenuse is just 2 times that. So 2 times 5 is just 10. So I'm going to write 10 divided by 3 times square root of 3. And just like that, we're almost done. We've solved a triangle. Now let's just find the perimeter by adding up all those sides. So I'm going to make some space here. The perimeter, let's just call it P, is just simply equal to 5 plus 5/3 times root 3 plus 10/3 times square root of 3. And notice that the 5/3 and the 10/3 can sum up to get 15/3, or that's just 5. So in other words, it's just equal to 5 plus 5 times the square root of 3. And we're all done with this problem. If you want to know what this is as a decimal, it is roughly 13.66. So I'm just going to write that down. Let's move on to the next one. Now, I've given you a square, and I want you to find the area of this square. We know that the diagonal is 3. How can we use that to solve for the area of a square? Well, to solve for the area of a square, you'd want to know its side length. For example, if I had these sides be called x, we know the area would be x squared, because the area of a square is just side squared. But what can we do to solve for x? Because I don't know what that is at the moment. Well, let me just isolate this triangle really quick, because notice we have a triangle right here. So let me just redraw that here in this corner and see what happens. We have 3x, x. Well, do you notice that this looks like a 45, 45, 90 triangle? Because remember, in a 45, 45, 90 triangle, it's a right triangle and the legs are of equal length. And when that happened, we knew that the hypotenuse was just equal to x times square root of 2. So in other words, we know that 3 is just equal to x times square root of 2. So I can just set up an equation and solve for x. So let me just do that really quick. 3 is just equal to x times square root of 2. And in the same process to solve for x, so I'll just go through it quickly. 3 divided by square root of 2 is equal to x, but to rationalize the denominator, multiply by square root of 2 for the numerator and denominator, and that will get you 3 times the square root of 2 divided by 2, and this is our x value. So that's awesome. But we're not done just quite yet. We know that the side length squared is the area. So to solve for the area of the square, we just need to square this value. So if I do 3 times square root of 2 over 2, and I square that, we'll be done. So let's review how to square a fraction like this. To square a fraction, you square the top and the bottom, like so. And then from here, we can just fill in the blanks. Fill in the numerator and the denominator. So the denominator is the easy one. That's just 4. And then for the numerator, you square both the 3 and the square root of 2. So it's just 3 squared times the square root of 2 squared. So if you do that, what you're going to get is 9 is 3 squared, and square root of 2 squared is just 2. So 9 times 2 divided by 4. And that's just 18 over 4. So the area of the square is just 18 over 4. And if you divide that to get a number, that is just 4.5. So the area of the square is 4.5 units. On to the next problem. In this problem, I've given you that the perimeter of this triangle is 30, and it's a 30, 60, 90 triangle, and I want you to find each side. The way that you can do this problem is to first set up the ratio again in this triangle. So let me erase these question marks and replace them with x root 3, and then 2x, because that's the ratio, right? And what do we know about these sides? If we add them up, you will get 30. So let me write that expression, and then maybe we can use that to solve for x. So I have x plus 2x plus x root 3. And this is supposed to be 30. Okay, well, I can group all those x terms together, right? So I just add the coefficients on those terms. So that would be 1 for the first coefficient plus 2 plus square root of 3 times x is equal to 30. And then now you might want to use a calculator to figure out how many total x's that is, because that's not obvious how much that is. Put this into a calculator and you should get about 4.73. So about 4.73 x's is equal to 30. And then if you solve for x, just simply divide by 4.73 on both sides, and you should get 6.34. Sorry, let me move out. There. And now we've solved for x, and we can plug that in to x root 3, and 2x to solve for each side. So x, that's the easiest one, is just 6.34. Let me write that in. 0.34. 2x is also pretty easy. Just multiply 6.34 by 2. And if you do that, you should get about 12.68. And then x times root 3, just do 6.34 times root 3 on a calculator. And if you do that, you should be getting about 10.98. And just like that, we've solved for all the sides in this 30, 60, 90 triangle given the perimeter. So it's possible to work backwards by simply setting up the ratio and then solving for x. Let's move on to our final problem of the day. For our final problem of the day, I've drawn a 45, 45, 90 triangle inside of a circle such that the hypotenuse of this triangle is the diameter of the circle. I've given you that the area of this triangle is 20, and I want to find the area of the circle. The first thing I'm going to do is find the lengths of the sides in this 45, 45, 90 triangle, and maybe that'll help us find the area of the circle. So remember, the ratio of the sides in a 45, 45, 90 is just x, and x times the square root of 2. But we know that the area of this triangle is 20, and we can use that to solve for the side lengths. How can we do that? Well, remember, the area of a triangle is just 1/2 base times height. Let me just rewrite that here. And the thing is, we know the base and the height of this triangle is just x. So I'm going to write that the area is equal to 1/2 x times x. And that simplifies as x squared. And we know that the area is 20. So now, if we solve this equation here, we'll solve for x and help us solve for how long the diameter is. So let's just solve this equation really quickly. 1/2 x squared is equal to 20. Multiply both sides by 2 to get rid of the 1/2. This gives us x squared is equal to 40. Therefore, x is just equal to the square root of 40. So now, what's the diameter going to be for this circle? The diameter is just x times the square root of 2, which is just equal to the square root of 40 times the square root of 2. Do you remember how to multiply radicals together? To multiply radicals, assuming they're the same type of radical like a square root and a square root, you just multiply the numbers inside. So 40 times 2 is just 80. So x times the square root of 2 is just square root of 80. And that's our diameter for the circle. Let me write that. And now what can we do? We know that the area of a circle is just pi r squared. But we have the diameter, and I want the radius. To go from radius to diameter, just divide by 2.